Hello students, welcome back to the math class. Today we are going to start from question number 3rd. As in the previous session, we have seen the definitions of the special kind of quadrilaterals like square, rhombus, rectangle, parallelogram, trapezium and kite. Okay, so all definitions I hope you must have seen. I have sent you the checklist also. With the help of that, each and every property you can check properly. Now we shall see from question number 3rd. On that day we have covered two more questions. First and second question also we have covered. So from question number 3rd we are going to see now. In this whole topic, the exercise 8.1, we shall deal mainly with the properties of quadrilateral, means special kind of quadrilaterals we shall deal, and we shall deal also with the congruency of two triangles, means whatever the task will be given to us, that task we shall complete with the help of congruency of two triangles. Okay, so now let us see the first question. In the first question, as you can see what we have given there, show that if diagonal of a quadrilateral bisect each other at right angle, then it is a rhombus. Means basically what we have given to us, one quadrilateral, okay, and their diagonals are bisecting each other at right angle. Means one diagonal divide the another one into two equal parts and they are perpendicular as well. So as you can see, I have drawn one quadrilateral over there, which may be looking in the shape of parallelogram or may be looking as a rhombus, but right now we cannot suppose them as any special quadrilateral. So here I am giving the name. First of all, I am giving the name first of all. So this first point I am giving as A, second point I am giving as B, third point I am giving as C, and this point I am giving as D. Okay, so now here the 4 points I have given, the point of intersection of the diagonal, that I am giving as O. So here one thing is given to us, that OD and OB are equal, OA and OC are also equal. Sorry, and also they are perpendicular to each other. Okay, so here we can say that first of all, what is the given things to us? The given things are, in quadrilateral ABCD, in a quadrilateral ABCD, we have given that BO is equal to OD, comma, OA is equal to OC. And second thing, we have given that at the point O, diagonal AC and BD are perpendicular. So AC is perpendicular to BD. Okay, what we need to prove here? We need to show that the given quadrilateral is a rhombus. So here in to prove, we will write down ABCD is a rhombus. Okay, ABCD is rhombus. Now see, what is the special quality of rhombus? You know that in rhombus all sides are equal. So here if we are able to prove all the sides are equal, then easily we can say that the given quadrilateral is a rhombus. So here that things only we shall try to prove it. So first of all, in the proof we shall write down, we shall consider here two triangles. So see, two triangles I am taking over here. First triangle I am taking here as triangle AOD, and second one I am taking as AOB. So here for our convenience we shall draw the two triangles. These are my two triangles over here. Okay, first one is triangle AOD, that I am taking here, AOD, and second triangle I am taking here as triangle AOD I am taking, and second triangle I am taking here as AOB. Now first of all, you see in these two triangles what are the things given equal to us. As you can see in the main figure, the side AO and side AO both are same, right? Then one more thing, OB and OD are given equal to us. OB and OD, we can say that they are equal. Okay, so that things we can mark first of all. So OB and OD are also equal. And second thing, since we have given that AC and BD are perpendicular, so angle AOB and angle AOD both are equal to 90 degree each. So here we can say that AOD is also 90 degree and AOB is also 90 degree. Okay, so we can say that these two angles will be equal to 90 degree each, and hence by side angle side congruency theorem we can say that triangles are congruent. So here first of all we shall write down in triangle AOB, in triangle AOD and triangle AOB. Okay, first AO and AO are equal. So AO is equal to AO, that we shall mention with the help of common. Second, angle AOD is equal to angle AOB, that is with the help of each 90 degree. We have given that diagonals are perpendicular to each other. And the third one is OD is equal to OB, that is with the help of given. It is given in the question. Okay, so we can say that therefore triangle AOD is congruent to triangle AOB. Okay, here reason we can write down by side angle side rule. Okay, now see, if these two triangles are becoming congruent, then we shall get two sides equal, means whichever are the corresponding sides, that we shall get equal. Already AO and OB and OD are equal, but we have remained one third pair, that is AD and AB. So we can say that AB is equal to AD. These two sides are equal with the help of CPC. Okay, and this we can give as equation number 1. Now if we follow the same condition, means suppose if I take the triangle AOB and triangle BOC. Okay, if these two triangles I take, AOB if I take and BOC if I take, then I can say that AB and BC I can show equal in the same manner. Suppose next time if I take BOC and if I take COD, okay, these two triangles if I take, so BC and CD I can show equal. And again if I take COD and AOD, then CD and AD also I can show equal. And if I compile that all, easily I can say that all sides are equal. And if all sides are equal, the quadrilateral will become here rhombus. Okay, so see, first of all what we shall write down at the last. Similarly we can show that we can show that AB is equal to BC, BC is equal to CD, and CD is equal to AD again. This will be my equation number second, equation number third, and equation number fourth. Okay, now if I compile all the four equations, so now you observe AB is equal to AD and CD is also equal to AD, then AB and CD are equal, but CD is equal to BC, so AB and BC are also equal. That is also we have shown, means if we compile all the four equations, then we can say that therefore by equation first, second, third and fourth, what we can say, all these four sides are equal. AB is equal to BC, is equal to CD, is equal to AD, or you can say D. And if all four sides are equal, then we can say that the given figure is a rhombus. So therefore ABCD is a rhombus. Okay, and that was only required to prove in the question. Now let us see the question number 4. What we have given in question number 4, let us see. Show that the diagonal of a square are equal and bisect each other at right angle. That is given to us. Okay, they are saying the diagonals of the square are equal and they are bisecting each other at right angle. First of all, let me take this figure this side, then we shall start the things. 1 minute. Figures are going unnecessarily on that side, so it is better we shall take the figure onto little bit over this side and then we can start the questions. Yes. Okay, now first see what we have given in the question. Show that the diagonal of a square are equal and bisect each other at right angle. Means we have given that a figure is a square. Okay, so remember, if the figure is a square, then three properties are applicable here. First property is all about the side. The all sides are equal and side opposite to each other are parallel. Second property is about angle. All angles are equal to 90 degree. And the third property is about diagonal. We can say that the diagonals are equal and they bisect each other at right angle. Means diagonals will be equal, they will be dividing each other into two equal parts and they will be perpendicular as well. So they are asking to prove the property of diagonal while it is given to us the first two properties are true. Means you can assume all sides are equal, opposite sides are parallel and all angles are equal to 90 degree. That is given to us. And then we need to prove that the properties of diagonal, like that the diagonals are equal, one thing. Second thing, diagonals are bisecting each other, means they are dividing, one diagonal is dividing the another into two equal parts. And the third thing that we have to prove, they are perpendicular as well. Okay, so let us see how we can prove this question. First of all, as you can see, the first figure I have formed here, this figure, the name I am giving as ABCD. So A, B, C, and this point I am giving the name as D, and here I am giving the name as O. Okay, here as you can know that the AB, BC, CD and DA we have given equal. Since we have given that ABCD is a square, so we can assume the property of the side and the property of the angles are true, and then we are going to prove the property of diagonal. So here I am supposing all the four angles are equal to 90 degree as well. Okay, so now first of all we shall write down in the given. In the given, first we shall mention ABCD is a square. ABCD is a square in which AB is equal to BC is equal to CD is equal to D. That is one thing we have given. Second thing, angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. This is second thing we have given. Okay, what we need to prove here, that we shall mention here. So we have to prove that property of diagonal. So we have to prove that diagonals bisect each other at right angle, means they are perpendicular also, each other at right angle, and they are equal. They are equal. They are equal. Okay. Now see here, whatever we have written, that we shall capitalize. First of all, we can say that, or first part we shall prove here, diagonals bisect each other, means they are bisecting each other, they are dividing into two equal parts. So we shall prove in this part OB is equal to OD, comma OA is equal to OC. Second part, they are bisecting at right angles. Okay, means the diagonal AC and BD are perpendicular. Okay, so here second part I am writing as AC is perpendicular to BD. And the third part, we need to prove the diagonals are equal as well. So AC is equal to BD. That is our third part which we need to prove it. Okay, let us write down now proof first. So in the proof, as you can see here, some figures I have formed for you. Okay, in this first figure you see, I am giving the name. This point is my A point. This is I am giving as A. 1 minute, I will write down once again. This point I am supposing as A. This is B. This one is C, and this one is D. And this point I am supposing as O. Okay, so see, we need to prove here OA and OC are equal, OB and OD are equal. You are looking here two triangles. One is AOD and second one is POC. If you see carefully, these two triangles actually I have taken from the main figure only. Okay, only I have not joined AB and CD. So you are looking a figure in a little different manner. Now one thing you see, if I ask you this angle number 1 and this angle number, if I mark here as 2. Okay, if I mark both the angle as 1 and 2 over there, then this angle I am marking as angle number 2. So angle 1 and angle 2 are which kind of angles? Observe carefully. Now you are enough matured about that angle 1 and angle 2 we can say definitely are of which kind? Angle 1 and angle 2 are of the alternate angles. And similarly, if I mark here in the same manner this angle and this angle, so these two angles are also, we can say, they are also alternate angles, and AD and BC are given parallel. So we can say that 3 and 4 are also equal and 1 and 2 are also equal. And since we have given that ABCD is a square, so AD and BC are also equal. So with the help of angle side angle, you can check. If I start with angle 1 and go to angle 3, in between that AD and BC comes. So angle side angle property we can apply, and we can say that triangles are congruent. Okay, since your question is already long, so I am not drawing the triangle separately. Okay, so first I am taking here in triangle O D A and triangle OBC. These two triangles we are taking it, ODA and OBC. Okay, here first of all we shall write down angle 1 is equal to angle 2. Second, angle 3 is equal to angle 4. Here reason can be given, since AD is parallel to BC and by alternate angles property. Alternate angles property, because if two lines are parallel, then alternate angles will be equal. So that these two angles we got equal. Second thing, we have given that in the question AD is equal to BC. that is given in the question. So we can say that therefore triangle ODA is congruent to triangle OBC. These two triangles are becoming congruent now. If these two triangles are congruent, then what do we get? See, we have proved the two triangles congruent just with the help of two angle and one side. So two pair of corresponding sides remain. That is also equal now. So we can say that OB and OD are equal over here. That is one of the corresponding side. And OA and OC are also equal. That is the third corresponding pair of side remain. So OA will be equal to OC. Okay. So we can say that these two pairs are equal. That is with the help of CPCT. And C, that is the only first part we were required to prove equal. As you can see, OB and OD are equal and OA and OC are equal. So we can say that diagonal bisect each other. So here first part is over. Here we shall write down therefore diagonal bisect each other. Okay. Now let us see the second part. Second part we shall prove the diagonals are perpendicular. So for that here I am giving the name. This point I am giving as B. This point I am giving as A. This is my O point and this one is B. As you can see, the same figure could be observed easily in the main figure as well. Observe it. On your left side, triangle DAB lies and in between that line OA is passing. Okay. So same way I have drawn the figure. I am just taking the part of the given figure to us. So here this triangle we have. In this triangle again we have two more triangles. So one triangle I am taking here OAD and second one I am taking here OAB. Okay. And in these two triangles I am taking, I will prove it the diagonals are perpendicular. So first of all, let us see in these two triangles what we have equal now. Just now we have proved OB and OD are equal. Okay. OA and OA are common and AB is equal to AD. That is given in the question because all sides are equal. So that is given in the question AB and AD are equal. So let us see now two triangles. We shall write down in triangle OAD and triangle OAB. Okay, first of all, we shall mention OA is equal to OA, that is common. One thing. Second thing, AD is equal to AB, that is given in the question. All sides are equal. Okay, and the third thing, we can say that OB is equal to OD. So we shall mention here OD is equal to OB, that we have proved earlier. We can write down the reason over here, proved earlier. Okay, so now you see all the three sides are equal. So with the help of side, triangles are congruent. So we can say that therefore triangle OAD is congruent to triangle OAB. So we can say these two triangles are congruent. Now if these two triangles are congruent, since I have not drawn the triangle properly, looking as a one-to-one correspondence, but if you draw it, this angle AOD and angle AOB, these two angles will be corresponding angles in the congruent triangle OAD and OAB. Okay, so we can say that these two angles will be corresponding and hence they will be congruent. So we can say that therefore angle AOD is equal to angle AOB. We can give the reason over here by CPCT. Okay. Now this one I can say as equation number 1. Now if I see these two angles, observe they are formed on one line, that is BD, and the line AO is passing from the angle BOD. Angle BOD is a straight angle. So we can say that the sum of angle AOD and AOB will be equal to 180 degree with the help of linear pair. So now we shall write down further, since angle AOD plus angle AOB is equal to 180 degree. Here reason can be given by linear pair. Okay. Now angle AOD and angle AOB both are equal. So in place of AOD, if I write down AOB, then also it will be okay because both are same. AOB I am writing as AOB only is equal to 180 degree. Reason can be given here by equation number 1. Okay. Now AOB plus AOB, same angle we are adding 2 times, so that will become twice of angle AOB is equal to 180 degree. Now 2 ones are 2 and 2 nines are 18. So remaining is, therefore angle AOB is equal to 90 degree. We can say that therefore angle AOB is equal to angle AOD is equal to 90 degree. And now observe the condition. Observe AOB and AOD both are becoming 90 degree each. If I show you the main figure, observe it carefully. Angle AOB, this one is becoming of 90 degree now. So in front of that angle COD, that will be not 90 degree, and we have also proved AOD is 90. So COB, angle COB will be also 90 degree here. Okay. So we can say that all the 4 angles are becoming of 90 degree, because if one angle is 90, in front of that the angle lies that will be vertically opposite angle, and hence it will be also 90 degree. AOB is 90, COD will be also 90 because it is vertically opposite angle, and hence all the 4 angles will be of 90 degree each. And we can say that therefore the diagonals will be perpendicular. So this complete the second part of the question. This question is lengthy. Okay. So therefore we can say AC is perpendicular to BD. This complete the second part, and we can conclude over here. Therefore diagonal bisect each other at right angles. Okay, means they are bisecting also and they are perpendicular as well. Let us take the last part. In the last part, now I am taking this figure. This figure little bit I will take it down. Let me select that one. First of all, we shall take this figure at this place, and first I will give the name. So this point I am giving as D. Figure is almost same the figure given to us, only I have not joined the line CD. Same figure I am taking. Okay, and this point will be O. However, O point is not required to mark, so O I am leaving it here. Okay, now this is the given figure to us. Now in this figure, first of all you observe, we are going to prove the diagonals are equal, means diagonal AC and diagonal BD, that I am going to prove equal, because that is the only one thing remain out of the 3 parts required to prove. First part we have proved diagonals are bisecting each other. Second part we have proved they are perpendicular. Now we are going to prove at last diagonals are equal. So AC and BD I am going to prove equal. So here you observe AD and BC is equal. One thing, because it is given in the question, all sides are equal. Second, AB it is common. Okay, and we have given that also in the question all angles are equal to 90 degree. If you see the main figure, then you will observe all the angles are also given as of 90 degree each. Okay, so with the help of side angle side congruency theorem, we can see that triangles are congruent, and then the diagonal will also become equal because they are the third pair of corresponding sides. So here first we shall write down in triangle. Now we are taking in triangle DAB and triangle CBA. Okay, first AD is equal to BC, that is given to us. Sorry, should cut this one. AD is equal to BC, that is given in the question. One thing. Second thing, AB is equal to AB, common. Okay, third thing, what we have equal here, angle DAB means angle AN only. So angle DAB is equal to angle CBA, each 90 degree, that is given in the question. All angles are equal to 90 degree. So we can say that therefore triangle DAB is congruent to triangle CBA. Okay, so therefore AC is equal to BD is with the help of CPCD. You can see the main figure. In that also AC and BD are the third pair of remaining corresponding sides. Okay, and now we are able to prove diagonals are equal as well. So we can say that therefore diagonals are equal, and we are able to prove the third part also. So this complete the proof of the question. Okay, so this question is very lengthy. Next question, question number 5 is also lengthy. Okay, but we do not have any option in this particular topic, that CBSE has not reduced any syllabus. So you have to cover the full chapter as well as it was given to us earlier. Okay, so you can see this question. Next time we can start with question number 5 onwards. Okay, thank you.